OpenStax Calculus Volume 2, we're working on integrating using partial fractions in Section 3.4, and in this video we're going to talk about repeated linear factors first. So we talked about linear factors earlier and the fact that if I have a linear factor, I have to have a constant numerator. But sometimes, as in this example right here, our linear factors get repeated. So if I have a factor that looks like ax plus b to a power, then I have to represent all the powers from 1 up to m. So I have to have ax plus b to the 1. I have to represent ax plus b to the 2. I have to represent ax plus b to the 3rd. And then all the way up to ax plus b to the n. Now, usually we don't have quite that many, but that would give me a, b, c, and then wherever we end up with our letters there. This is where they use the a sub 1, a sub 2, a sub n, but I like it better this way. Now, what happens a lot of times is one of our factors might give me a 0 on top, and that's okay because that one goes away. But it could be that you use them all, and that's okay too. So the first thing we look at here is that our top degree is 1, and on the bottom, because we have 2x minus 1 squared and then x minus 1, we really have x to the 3rd on the bottom if you were to put it all back together. Because the 2x minus 1 has a power, when I do my partial fraction, I'm going to have 2x minus 1. Then I'm going to also have 2x minus 1 squared. Still a linear factor. We still have a constant numerator, plus c over x minus 1. That's only there once because that's all we have. Now, keep in mind when we do our common denominator, we don't need 2x minus 1 3 times. We only need it twice to match. So we need our denominator to look like this, like the original. That means that here we would multiply by 2x minus 1 and x minus 1. 2x minus 1, x minus 1. Here we just multiply by x minus 1. And on this last one, we multiply by 2x minus 1 squared. So we have a little bit of algebra that we need to do. I'm going to take my 2x minus 1, x minus 1 over here. That's give me 2x squared minus 2x minus 1x plus 1. So that'd be 2x squared minus 3x plus 1. So when I distribute my a to that, I have 2a x squared minus 3a x plus 1a. Next, my b is pretty easy, plus bx minus b. Here, the 2x minus 1 squared gives me a 4x squared minus 2x plus 1. 4x squared minus 4x plus 1. So we have plus 4c x squared minus 4cx plus c. Now, our original numerator was x minus 2. So we have our x squares, our x's, and our constants. For x squares, we have 2ax squared plus 4cx squared. So we're going to say 2a plus 4c equals 0. For our x's, we're going to have minus 3ax plus bx minus 4cx. So let's see. Negative 3a plus b minus 4c equals 1, because you only had one x in the original. And then what's left is our constants. We have a minus b plus c equals, our original had a minus 2, so negative 2. So to give you complete honesty, I just had to go back and erase where I had solved for a, b, and c because I missed one sign and it screwed up my whole thing. So here, 2a is negative 4c, a is negative 2c. So if I plug that in, let's see, here, negative 3 times negative 2c, I have 6c plus b minus 4c equals 1. So that would be 2c plus b equals 1. Over here, if I put in negative 2c, I get negative c minus b equals negative 2. So either one of these I could solve for b, or I could solve for c and plug into the other. I'm going to go right here and say b equals 1 minus 2c. So I'm going to come over and say negative c minus 1 minus 2c is negative 2. Negative c minus 1 plus 2c is c minus 1 equals negative 2. C equals negative 1. If c is negative 1, then b is 1 plus 2 is 3. And a, negative 2 times negative 1, is 2. So 2, 3, and negative 1. So if I use this template to rewrite my problem, I have the integral of a, which is 2, over 2x minus 1 dx, plus b, which is 3, over 2x minus 1 squared dx, plus c, which is negative 1, so I'm going to change that to minus, over x minus 1 dx. All right, coming back through, if u is 2x minus 1, du is 2 dx, which works out absolutely perfect because we've got our 2 right there. So this is the ln of 2x minus 1. Plus, if I say that this is 2x minus 1 to the negative 2, I can use my power rule here to make this into, if I add 1, it's a negative 1 power divided by negative 1. So we're going to have to do some simplifying. That's okay. 2x minus 1 to the negative 1. Oh, no, I got to have some more than that. Okay, hold on. Go back. So if I wrote it as 2x minus 1 to the negative 1, u is 2x minus, or sorry, to the negative 2. du is 2 dx. So I need a times 2 and a 1/2. And then this would be u to the negative 2. Okay, so I have 1/2. And then this is 6. Nope, the 2. All right, guys. I'm going to confuse me and you if I'm not careful. So let's move over and look at just this one piece. We have the integral of 3 over 2x minus 1 squared dx. If we said that u was 2x minus 1 and du was 2 dx, that means that I need a 2 with that and a 1/2 out here, and that this 3 isn't doing me any good at all. So I'm going to rewrite this as 3/2 integral of u to the negative 2 du, which is going to be 3/2 u to the negative 1 over negative 1 plus c. That's going to be negative 3/2 2x minus 1 to the negative 1 plus c, which is negative 3 over 2 times 2x minus 1. Okay, now that I unconfused me and I hopefully unconfused you, I'm going to go back and put that into my problem. So I have, for my second part of my integral, negative 3, so I'm going to make that a minus, over 2x minus 1. Here, u equals x minus 1, du is dx. So this is ln x minus 1 plus c. Not bad.